All right, for our warm-up today, we need to remember a skill that we learned yesterday. So we learned something about cubes yesterday. If you have something like this, which our first warm-up is in this form, it's something cubed minus something else cubed. Remember, it's whatever you were cubing in the front minus whatever you were cubing in the back. The first one squared. The first times the second one squared. As you're going through this, your sign should be the same as the one in the problem, the opposite, and then a plus sign. So, in our first warm-up, A is x in this case, B is 5 in this case, because x is being cubed in the first term, 5 is being cubed in the second term. And then you're basically just filling in the blanks. So we want x minus 5. Remember, the binomial always has the same sign as the one in your problem. Then you want the a term squared. This is going to be the opposite sign as the one in your problem. A times b, and then b squared. And remember, it's always a plus sign at the end. So this is how we factor the first warm-up. What are your questions on that one? If you were absent yesterday, this was basically the only new thing we did. Everything else we took other skills we've already learned and just applied them to problems with larger exponents. This is in your book. In section 6.4, there's also one where it's a sum of cubes. We'll look at one like that later today. But that's one of the main things that you missed if you missed class yesterday. All right, how are we going to factor the second one? We didn't look at a lot like this yesterday, but it is something you already know.
Cube 6. Or do you put the 6? Do you take the 6 out?
You can't take a 6 out. What can we take out?
3.
A 3, good. We can also take out an x, good. So that would leave us with 2x plus 5. And that's all you can do with that one. What are your questions on our warm-up today? Today we are finishing what we started yesterday, 6.4. Yesterday we did a lot of factoring. Today we're going to do the solving aspect of these. So our goals today to factor polynomial expressions. We'll practice that for the first few examples. And then we're going to start solving them when they're factorable. All right, so we are going to do some review problems. I think the first 6 or 7 are review, and then we'll get into the new stuff today. So this first one is just factoring a trinomial. How do I factor something like this? Yeah, multiply, add. And remember, the first times the third is your multiply number. So our multiply number here is negative 24. Our add number is negative 5. So what would we get? Yeah, the 8 needs to be the negative. So it would be x minus 8, x plus 3. Now, we are not done. Remember, we are using the bottoms-up method, so we have to go back and divide by our lead coefficient. Our lead coefficient here is a 2. 8 divided by 2 gives us a 4. We cannot simplify 3 over 2, so we just move the bottom up. And we end up with x minus 4 times 2x plus 3. If you want to check your work, go ahead and double distribute. You would get 2x squared. Your middle terms would be positive 3x and negative 8x, which gives you negative 5x. And then your last term would be negative 12. What are your questions on number 1? Again, this is a review problem. How would I factor this one? It's a difference of 2 squares. Good. So the square root of the first term goes in the front. The square root of the second term goes in the back. One gets a plus sign, one gets a minus sign. Again, you can double distribute to check your work. The middle terms would end up canceling out, leaving you with just 4x squared minus 9, so we're good. Number 3 is a difference of squares or cubes? Cubes, good. So this is where we need to decide what A and B are.
X and 3.
Very good. So I have A equals X, B equals 3. This is where we have a binomial with the same sign as we had in our problem. Then a trinomial with the opposite sign and a plus sign. And then you're basically just filling in the blanks. So I want A and B. A squared, A times B, B squared. Questions on 3? Here's 4. 2 x. Very good. Don't forget your variables here. So A is 2x, and I know that because the cubed root of 8x to the third is 2x. The cubed root of 1 is 1. Again, we set up a binomial with the same sign as the one in our problem. A trinomial with the opposite sign and a plus sign. And then you're just filling in the blanks. I want A, B, A squared, A times B, B squared. Again, if you double distribute here to check your work, all the middle terms will end up canceling out. And you'll end up right where we started at 8x to the third plus 1. Questions? As I look at number 5, I know I can't do the MA method because there's not 3 terms. I know it's not a sum or difference of squares or cubes because there's not 2 terms. So what's the only way we know how to factor something with 4 terms? I know what you're saying. Grouping. Good. I heard somebody say it. That one method with the parentheses. I saw you making parentheses. Okay? And remember, whenever we put the negative in with the 9, squeeze a plus sign in there so you don't think you're supposed to double distribute. What can you factor out of the first 2 terms?
X squared.
Very good. X squared. That leaves me with an x minus 2. What can I factor out of the next 2 terms? And remember, the goal is to end up with x minus 2 in parentheses. Yeah, you need to factor out a negative. So that'd be x minus 2. What you pulled out becomes one binomial. The leftovers becomes the other. Are we done? No, we are not done. Why? That's a difference of 2 squares. Good. So now I have x minus 3, x plus 3, x minus 2. Wonderful. All right. Next. What do we think? Yeah, it's definitely a difference of 2 squares. What's the square root of 81x to the 4th? 9x squared. So I'll have 9x squared and 9x squared. What's the square root of 16? 4 and 4. 1 gets a plus, 1 gets a minus. Am I done? No. Why am I not done? Yeah, this is still a difference of 2 squares. This can be factored again. Can this be factored again? No. Sum of 2 squares is nothing special. Okay, difference of 2 squares, though, is, so I have 3x minus 2, 3x plus 2, 9x squared plus 4. Now I'm done. Any ideas how to start number 7? Yeah, take out a 4. Anytime they have a greatest common factor, that's what you need to do first. So this is x to the 4th minus 5x squared plus 6. Now I can do multiply add. So multiplies to 6 adds to negative 5. So I still have the 4 out front. Does anyone know two numbers that multiply to 6 add to negative 5?
Negative 3, negative 4.
Very good. So I have x minus 3, x minus 2. Is that correct? No, what am I missing? The squares. Good. If your first term is x to the 4th followed by an x squared, when you factor it, these need to both be x squareds. Now, since we're doing bottoms up method, we'd have to go back and divide everything by a 1. Remember, dividing by 1 doesn't change anything, so I am done after this step. What are your questions on number 7? So today we're going to start solving these binomial equations. So we just looked at how we factor them. That was kind of a review of yesterday. Now we're going to actually solve these. We solve polynomial equations the same way we solve quadratic equations that are factorable. So you want to get all your terms to one side of the equation. You want to factor it. We set each factor equal to 0. Remember, we learned something called the zero product property that says if 2 things or 3 things or 4 things multiply together to give you 0, you can set each piece equal to 0 to find your solutions. And then we solve each mini equation that we set up. If you're writing this down, I would not write this part. I would just write the steps. It'll be a lot quicker for you. As we go through these, though, you'll probably notice that these steps feel kind of natural. Like I said, it's very similar to what we've been doing, solving these in Chapter 5. Number 8 is actually a problem that I could have given you in Chapter 5 because it's an x squared. So technically you already know how to do this one, but I just wanted to remind you of how we did these previously so you could see how similar the new ones are. So how would I solve something like this? Yeah, remember, you want to get everything to one side. So 3x squared minus 9x equals 0. Then we want to factor. Can we factor this?
Yes.
What do I pull out?
3x.
3x, good. That leaves me with an x minus 3 equals 0. Now we use what we call the zero product property, and you set each piece equal to 0. So 3x equals 0, x minus 3 equals 0. So I'm getting x equals 0 as a solution, and x equals 3 as a solution. Now, I'm going to give you guys a hint here. Your biggest exponent, your degree of the polynomial, is how many solutions you should end up with. So if it's an x squared, you should end up with 2 solutions. If it's an x cubed, you should end up with 3 solutions. X to the 4th, you should have 4 solutions. Okay? Any questions? Here's our next one. Again, this is one you should know how to do. How should I start this? Subtract 2x and 15. Good. We want to get everything to one side. Remember, we always want the x squared term to be positive as well when we're factoring. So now it looks like this. It's a trinomial. How do I factor trinomials? Multiply, add. Good. So it multiplies to negative 15, adds to negative 2. So what is it? Negative 5 and positive 3. Now I can use the zero product property, set them each equal to 0. X minus 5 equals 0. X plus 3 equals 0. So I'm getting x equals 5 and x equals negative 3.
So when you add a 0 when it's a equal sign in there?
Yeah, anytime you're solving an equation, you want to get everything to one side, factor it, and then we use the zero product rule because when you have two things multiplied together to equal 0, you can set them each equal to 0 and solve. So that's how we end up with these two solutions. When there's not an equal sign, you just factor. When there is an equal sign, you get everything together equal to 0, and then you solve. All right, here's number 10. How should I start number 10?
Yes, me.
I'm asking the whole class.
Oh, I thought you said Eric. Yeah.
Oh, no, I don't think I did.
Well, Eric, do it.
Oh, but Eric, yeah, you can go ahead and do it. Anyone know how to start this one? Yeah, we want to get everything to one side. So we're going to subtract 16x. So I have 4x to the third minus 16x equals 0. Yeah, we can take out a 4x. That leaves me with x squared minus 4. Anything else we can do? This is a difference of two squares. So we want to do that before we set everything equal to 0. Yep. So now each piece can be set equal to 0. Alright, so in the first one I divide both sides by 4. 0 divided by 4 gives me a 0. The next one I'd add 2 to both sides, I'd get positive 2. The last one I'd subtract 2 from both sides, I get a negative 2. So those are my three solutions. My exponent is a 3. Remember, always go back and double check. Sometimes you'll have less if one of your factors is the same as the other one. You only have one solution, or two of them will have the same solution. But in general, you should have the same number of solutions as your largest exponent. Questions? All right, here's number 11. What's the first thing I should do? Subtract 2. Good. So we have x to the third plus 2x squared minus x minus 2 equals 0. There's 4 terms. How can I factor something with 4 terms? Grouping. Good. So I can bring an x squared out of the first one. That gives me x plus 2. So what do I need to pull out of the second one? Just a negative 1. Good. So your greatest common factors become one binomial. Your x plus 2 becomes the other binomial. All still equals 0. Anything else we can do? Yeah, difference of 2 squares up front. So I have x minus 1. I have x plus 1. I have x plus 2. All equal to 0. Now we can use what we know about the zero product property. So x minus 1 equals 0. X plus 1 equals 0. And x plus 2 equals 0. When you solve those, I am coming up with 1 as a solution, negative 1 as a solution, and negative 2 as a solution. Again, exponent of 3, 3 solutions, we're good. Questions? All right, here's number 12. There are 15 examples today, if you're wondering when this will be wrapping up. What's the first thing I should do on number 12? Bring out a 3, good. So we have x to the 4th plus 5x squared minus 24 equals 0. Now what? So multiply to negative 24, add to positive 5. Anyone know what it is? Positive 8 and negative 3. Remember, the larger one always takes the sign of your add. So once you decide it's 8 and 3, we know the 8 has to be the positive one because the add number is positive. What did I forget? It's so easy to forget the squares. Even I do it. All right. Now, we can't factor any of those further, so I can set each one equal to 0. This is where it gets a little bit different than what we've been doing in the past. Now, does 3 ever equal to 0? No. There's no x's up there. There's nothing to solve. There's nothing going on up there. How would I solve something like x squared plus 8? Very good. You got to subtract the 8, and then you take the square root. So I have plus or minus. What's the square root of negative 8?
2y.
I hear some people that are getting close. We have to do a factor tree for 8. 4 and 2, 2 and 2. So these 2's will come out. So I'll have plus or minus 2. What else needs to come out? An I. And then in the square root, I still have a 2. That gives me 2 solutions. Positive 2i square root of 2, negative 2i square root of 2. All right, I need to do the same thing for the 3. So I have x squared equals 3. Take the square root. X equals plus or minus. You can't simplify the square root of 3, so I just leave it square root of 3. So just to show you that there are 4 solutions, I'm going to list them out on the top. So I have 2i square root of 2. I have negative 2i square root of 2. I have positive square root of 3. I have negative square root of 3. Those are my 4 solutions. I had an exponent of 4, so that makes sense. Now, there is a section in your homework where it says give all the real solutions. 2 of those are not real solutions. Which 2 are they? The which ones? Negative numbers can be real numbers. What makes it not a real number? The i's. If the directions say only give them the real solutions, cross out anything with an I at the end. Okay? These directions just say solve, so I'm going to leave all 4 of them up there, but be aware of that on your homework. If it's asking for real solutions, anything with an I has to go out. Any questions on number 12? All right, here's number 13. Very similar setup to number 12. How am I going to start this one? Bring out a 2, no x. The 72 doesn't have an x. So this is just x to the 4th minus 13x squared plus, what does that give you, 36 equals 0. Just like the last one, we have a trinomial, so we can do multiply, add. Do you guys know 2 numbers that multiply to 36 but add to negative 13? Negative 9, negative 4, good. Now, what is special about the negative 9 and the negative 4? They're both difference of two squares, so we can actually make this x minus 3, x plus 3, x minus 2, x plus 2 equals 0. Now you set each factor equal to 0, so 2 equals 0, x minus 3 equals 0, x plus 3 equals 0, x minus 2 equals 0, x plus 2 equals 0. These are very easy to solve, unlike the last one. 2 equals 0 does not have a solution. There's no variable, so just forget about it. We get positive 3, we get negative 3, we get positive 2, we get negative 2. If you wanted to be very short about your answer, you can say plus or minus 3, plus or minus 2. That gives us 4 solutions. They're all real numbers, so the real number directions don't really apply here. Whether it said solve or solve only giving real solutions, all 4 of those still work. The largest exponent is a 4, so we are good. Questions on this one? Kind of a neat problem. Yep. These are both numbers cubed. So I have to use that sum of cubes that we learned yesterday. What's the A value here? What's the B value? 3. So I will have x plus 3 because my problem had a plus sign. X squared minus 3x because that second sign is the opposite of what was in your problem. And then plus 9 equals 0. Now, set each factor equal to 0, so x plus 3 equals 0, and x squared minus 3x plus 9 equals 0. Well, the first one's easy to solve, right? I just subtract 3 from both sides. So there's one solution. Can we factor x squared minus 3x plus 9? Multiply to 9, add to negative 3. The only way to get 9 is 9 and 1, 3 and 3. That's not going to work. So we know 2 other ways to solve something like this. Do what? Yeah, we can subtract 9 and complete the square. However, do we want to divide the 3 by 2 and square it? I wouldn't do that method, personally, because the b is an odd number. I don't know why I only complete the square and b is a positive number, or an even number, excuse me. What's the other way? I could complete the square. I'll get some messy fractions. The other way to do it is to... We already tried multiply add. It's not going to work. Negative b plus or minus the square root. Yeah, the quadratic formula. Good. So I have negative b plus or minus the square root of b squared. That's going to be 9 minus 4 times 1 times 9 all over 2 times 1. What do you get inside those parentheses, or inside the square root? Yeah, you get a negative 27. So I know I'll have an I in there somewhere. I can do a factor tree for 27. That's 9 and 3, 3 and 3. So I'll have 3 plus or minus 3i square root 3 over 2. That gives me 2 solutions. Over here gives me 1. So 1, 2, 3. My largest exponent was a 3, so I'm good. Now, if the directions specified only give real solutions, what's your only actual solution here? -3. So read the directions. If they're only asking for real solutions, cross out anything with an I when you get done. Questions on 14? Kind of a tricky one. Don't forget what you know about solving quadratics as you're going through these. If you get stuck, use the quadratic formula or complete the square. All right, here's our last example for today. Ideas on where to start? Good, add 16x. So we have x to the third plus 8x squared plus 16x equals 0. As I was doing that, I noticed they all have an x, so I'm just going to pull that to the front. That's x squared plus 8x plus 16 equals 0. Is that going to factor? Yeah, multiply to 16, add to 8. 4 and 4. So this is going to be x plus 4, x plus 4. And don't forget you have that x out front. That'll change things. Alright, each factor equal to 0. X equals 0. X plus 4 equals 0. X plus 4 equals 0. So x equals 0, that's already solved. 0 is a solution. You get the same thing for these two equations. You only have to write it once, okay? So x minus 4, you only need to write once. This is the only case where you will not get the same number of solutions as your largest exponent because you had the same solution twice. You don't need to list it twice. We just know that it actually appears twice. So here you only have 2 solutions even though your largest exponent is a 3. What are your questions on this section? All right, here's your homework assignment. It's the exact same assignment as yesterday, so just go ahead and finish it up. It is a lot of problems, I understand. Your homework check is not till next Monday, so you got about a week to do these. Let me know if you have questions. We'll go over them at the beginning of class tomorrow.